I set it up, and it had to be like 2 or 3 minutes in. All of a sudden, the computer started restarting, and then it didn't come back all the way. So there was, I, I, I had to draw rasters on the board, is where it came down to.
It's all understandable. The storm yesterday had our internet going in and out, so I wasn't really able to stay on it for class anyway.
But if my computer hadn't shut down, I should have been able to record it at least for you. But I ended up with nothing. So I'm glad you could do this, because this isn't complicated, but it takes a little bit to sort of wrap your head around what's happening sometimes.
Okay.
So can you see my land cover that I've got on the screen here?
Yes, I do.
All right. So I've got 2 different dates in the lab. I don't know if you've looked at what was in the lab, but you're going to use Houston. This is the Atlanta data.
Okay.
Okay. So 92 and 2006, and you can see that Atlanta's grown a fair amount. Okay. So what the purpose of the lab, if you've when you get into it, is sort of to figure out what's changed over time by using some raster masks. So I mean, if you get growth like you're seeing here, if I have more developed, which is what the red is, then that means I have less of something else that used to be either maybe agriculture or wetlands or forest and is now developed.
Right.
Okay, so this is a pretty common way of doing this. And what you do is use a reclassify tool. And I guess we're going to find out whether I turned on my extensions. Either one, 3D analyst or spatial analyst, doesn't matter, same tool.
Oh, okay. See, I always use the spatial analyst one because we haven't really had to do 3D with it yet. So I didn't know if there was a difference.
Yeah, so this is the spatial analyst.
The
3D analyst is exactly the same.
Okay.
It goes way back to something called ArcView. I don't understand either. Okay, what I want to do is I want to create a raster from the 1992 data that shows just the forest, and I'm going to group all the other classes together into their same class.
Okay.
So let me add that, and I'm actually going to open as it loads. Okay. And that's not going to let me do it. No, and that's right. It didn't let me do that in class. So how this land cover data works, the data I give you, you can actually open the attribute tables for the lab. Water is coded as 11. Forest is in the 40s, like 41, 42, 43. The developed is in the 20s. So they sort of group the common land cover types together like that.
Okay.
So I want to select just the forest, and I'm going to set everything else to 0 in my new raster. And let me find my tool here. By default, this reclassify tool comes in with these ranges.
Yep.
But I want to see the actual values in the raster. So if I click the unique button, it basically goes into the raster and pulls out the values.
Yep.
Okay, so here's my water, here are my developed. You have metadata for this. I think these are like extraction I'm just going by memory. These are definitely forest.
Okay.
Okay. And you can see it keeps going. These are wetland, and I think these are some form of agriculture. So old values, new values in a new raster. And I'm just going to, anything that's not forest is going to be 0. Anything that is forest, I'm just going to set to 1. So this is called I've heard it called a binary mask. I've heard it called a Boolean raster. It's only got 2 values, 1 and 0.
Yep.
All right. Just a quick double check that I didn't miss anything. Looks pretty good. Okay, so I'm going to write this Where am I writing this to?
Not to sonar.
No. And let's call this see if this is too long a word.
Okay.
Okay. So
Yeah,
if it's
okay.
0, it was something else in 1992. And if it's a 1, it was forest.
Okay.
And so 0 is the, okay, that makes sense. I was like, why are these straight lines forest? But they're not. Now, to figure out what happened to forest in the 2000s by 2006, I'm just going to use the times function. You can use raster calculator if you've used it before. We're just multiplying them together. So order doesn't matter. So I'm going to say the forest mask times the 2006 data. I'm going to call my output changed forest. And I'm going to click OK. It's a little messy.
Yeah, but
Yeah. But how it works, if I did it right, now I'm wondering if I did it right.
there's a lot of changes.
If I didn't goof. Because I wasn't paying attention, I'm thinking about talking. Let me go just make sure I ran it right, because I was expecting more zeros.
Well, it looks like 0 is your water. A lot of water anyway.
Okay, I did. So forest mask, 0s and 1s times the 2006. Well, that looks right. Anyways, so what should happen is any pixel that got multiplied by 0, okay, any pixel from 2006 that got multiplied by 0 is still going to stay 0, right?
Okay.
0 times anything is going to give you 0. And those were pixels that we didn't care about from the 92 data.
Right.
Because we called them 0 to begin with. They're anything but forest. If I end up with a value, it means it used to be forest. And in this case, 41, 42, 43, it's still forest. But sometimes it changes. Okay.
Okay.
So I've got some 11 here. That means because it's not 0, it used to be forest and is now water somehow.
Okay.
We're going to ignore how that could possibly happen. That's a whole remote sensing thing. Maybe there was a flooding, but we're not concerned about that. We're just concerned with the numbers that are appearing here. The 21s, 22s, and 23s and 24s, what were the 20s? Do you remember from me just talking?
Developed?
Yep.
Okay.
So that means they were forest and are now developed.
Okay.
Okay. Again, the 40s were forest and still
Forest, and
forest.
then above that was like wetlands and agriculture or something.
And so when you have something that's not 0, it means because we multiplied it by the forest mask, what was 0 or what was forest is now something else.
So you do have a lot of 22 around the area that was showing urban development between 92 and what was it, 2006 or whatever? Yeah, 06. So yeah, that does make sense there. Okay, now that we're looking at it like that, that does make sense.
And here, because now I can actually look at my attribute table. Here are my results. So this is the number of cells. Okay, if I add these all up, that's my total.
Yep.
This is the attribute table for this changed forest. I should have a lot of zeros because I had a lot of zeros in my first one.
Right.
My forest mask. Okay. So those are things that were not forest in 92. We don't care about. I should have a lot. Usually, I mean, classes stay the same for the most part.
Yeah, over 20 years.
Yep. So 607. So a lot of the forest stayed forest. A lot of the forest got changed, developed. Okay, where I got this 18 or 1,801,000 pixels or cells. Okay.
Yeah.
So that's how you read this. What do you think? Questions?
No, wouldn't it be easier to all have like those specific ones like 21, 22, and 23? Wouldn't it just be easier if they were all just one number?
It could be, but it would force you to do sort of another reclass on the 2006 data in order to get those as one number. There are different levels of, and it sort of depends on the use. So it's different levels of development. I think the 24 is like, heavy industry and that sort of thing. The 21, it could be like residential.
Okay.
Okay. For like forest is simply hardwood, softwood, and mixed. That's what the 40s are.
Okay.
All right. So you'll have metadata in the lab for today, or that we did yesterday, and you're going to work on. That will explain what the codes are, what the numbers mean for each class.
And so this reclass is showing the difference of, like, basically this is showing like all these extra numbers that are not zero is loss of forest or forested area, other than the 41, 42, 43, because they stayed what they were supposed to be.
Right. I get a little, when people say loss of, I'm like, well, it's not totally lost, right? Because some of it stayed the same. Some of it got turned into agriculture. Some of it turned into water. Some of it turned into wetland, which seems a little odd.
Well, I was thinking about that. I just did something. My capstone is the black ash kind of suitability model. Even though one was done a couple years ago, out of that suitability model, none were found within the areas that was supposed to be suitable locations around Paul Smith's. So I'm now trying to dredge up all the layers to make a suitability model for black ash within this area. But I ended up finding that we had a lot of loss of wetland in New York State, like 22,000 acres or something like that of it. But we also had a gain of 33,000. So we now have more wetland than we used to have, but it means that it's moved then, which means that the suitable areas that were wetland for black ash are now not so suitable, specifically for the basket making black ash. And now I don't know what the frick I'm supposed to do.
I hadn't even considered the whole, if you're going to destroy a wetland, you got to build a wetland thing.
And it takes time to grow a damn tree. So, and if you're putting a wetland in,
I know the algorithm they've used. So this was all built from remote sensing data, from Landsat data. And I know the algorithm has sort of changed over the years. They've tweaked the algorithm to get better results. So there's going to be some changes based upon that too.
Okay.
But that's more in depth. That I'm really just trying to show you this technique, and how it's applied. And it's a really simple technique, and it's pretty useful too.
Yeah.
And you can go backwards. You can say, well, I have all this developed area. What did it used to be? And we could reclass the developed to ones, set everything in this data here. We could say,
and then you would times it by
92 data to see what it used to be. Okay, so you can work backwards. One thing to be careful of. So I went into OpenEdge. I've got these selected. And that's why everything now looks blue.
Yep.
If I run something on these, it will only use the selected pixels.
Yeah, I just did that with my final for it took me forever to just try to make a locator map because I ended up deleting data because I had stuff selected and I was like, oh, no.
Yeah. Yeah.
And had to re-download stuff.
So there were a few people yesterday going, they because they had 0 selected or something, they'd run it and it would only process the 0 pixels, which meant the next layer they got was only zeros. They're like, Ross, something's happening. And we'd clear the selection, we'd rerun it, and it would work fine. Now, the one other thing that can happens is, so the last overlay I have you do is I actually have you create a wetland mask and a forest mask together. So you have to assign a value to wetland and you have to assign a value for forest, and then everything else is 0.
Okay, so it'd be a 1, a 2, a 0, 1, and 2.
Okay, here's the thing. If you use 2 times 21, so if I say forest is going to be 2 and wetland is going to be 1, 2 times 21 is going to give me 42, right?
Right.
Well, if the wetlands are 1 times 42 is going to give me the same value.
Oh, well, that's not very fun.
Right.
Do I have to do a union then? Do I do a mask of each?
No, we just got to use something other than 2.
Oh.
So just, so what I do, so for, because I've done this a few times, I've learned some tricks, but what I have to do is I would sort of like, okay, I'm going to use 1. 1 always works. 0 is going to work. I know that for what I'm trying to do. What number can I use for my last class that I'm not going to cause confusion? And I set up a little thing in Excel or like not a Punnett square, but something like a multiplication table or something with checking out a value that'll work. Okay, that's not going to give me sort of that class confusion, because all you get in the output's 42. It doesn't tell you where it came from.
So, so maybe I'd go 1 over the amount of classes that I have.
What do you mean 1 over the amount of classes?
So say it was like 63 or something like that. But just do 6. Oh, Jesus. Maybe not. Sorry.
No, it's okay. It's okay. That's what I meant.
All right. Yeah, because if you did 5 times something, because it's an odd number and you're thinking that you might not get, whatever, any 5 or 0 is going to be classified at, wow, there's a lot in there.
There's actually only 2, 90 and 95 are the only ones that would you get?
Oh, okay.
Maybe 5 would work. What's 90 divided by 5?
45.
No, that's 2.
Oh, right.
I did that in my head earlier too, so don't, yeah.
Sorry.
No, I exactly was thinking that a moment before. So 90 divided by 5 is 18. There's no 18s, so 1 and 5 would work, I think. 95 divided by 5. Yeah. I think you'd be okay. It'll be a little disconcerting to look at your final tables.
So everything would have to be either divided by, well, everything would come up as either a 0, a 1, or another number. And if the other number is divisible by 5, then it's supposed to be the other one.
Yeah,
Wetland?
so you'd end up with something like this, actually. But you'd also have 55. And then, so your next highest number is 21.
25.
So you'd have 105, but actually, so 5 is not too bad.
Okay.
Because if it was 5 and then it turned into water, which would be 11. So you're going to multiply 5 times 11. That would give you 55. and you have no 55s in this data. And then 5 times 21 would give you 100. So everything above 95, except for the 55, would mean it was that class of 5. And I just spoke way too quickly, probably.
No, that makes sense. Anything over the 95 would end up being changed to wetland or from wetland, a change from wetland, right?
From wetland, though you are still going to have some stuff that stays wetland. It'll be 5 times 90 or 5 times 95.
Okay.
So 450 and 475 would be, it was wetland and is still wetland.
Okay. Yep.
All right. Yeah, that's, except for that 155, which meant it was wetland and is now water. That would be the only exception to that.
Okay.
Because it's 5 times 11 would give you 55.
Yep.
Okay. That was pretty much what I wanted to cover. I'm trying to think of what else. I think that's about it. I mean, I talked a little bit about the Mosaic to new raster tool in class. Because when you do that for the second half of the lab, you're combining a bunch of DEMs, and that tool says how many bands are there, and because you're only dealing with elevation, it's a single band.
Okay.
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 Let me see. I can. So this would be where you input your rasters, your output location. Don't put this one in a geodatabase.
Yep. I heard you saying that.
Yep. Yeah, this tool just does not like that. And then here where the number of bands is just 1 because you have multiple rasters, but they're all just elevation.
Okay.
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 That's way easier without a bunch of people in the class.
Yeah, I do much better one-on-one anyway.
Okay. I don't have anything specific here that I want to go over now. I think I covered everything I wanted to hit. Is there anything, I mean, do you want me to do another one, or you feeling okay?
This works.
Okay.